Hello and welcome back to another Mr. Walker's Chemistry. Today we're going to be taking charge, and I mean that quite literally. Our atoms will begin taking on charges, which means that they will be called ions. So we're going to be learning about ions here today, okay? This is our key word for the day, ions. So, what is an ion? Well, that's one of the things that we need to learn. So as always, by the end of this video, you should be learning some information. You should be able to define what an ion is. Okay, so if your mom or dad says, "Hey, Johnny, what's an ion?" Okay, then you should be able to identify that for them. Okay, you should also vaguely be able to describe how ions are formed. We're going to get more into the specifics throughout chemistry. Particularly because this does involve electrons, which, as I said in the electrons video, is a very important concept in chemistry, knowing what electrons are and how they move around and stuff. We're going to deal with them a lot throughout the year. And how to calculate the charges. Okay, some of this was done a little bit in the practice with the electrons video, but we're going to be giving those things names more so in this video, and really just doing lots and lots of practice. Definitions are easy enough. You can memorize them, you can understand them, you can describe things, but being able to do the math, of course, just takes practice and practice and practice and practice. So we're going to do lots of practice with these sorts of problems. Alright, so ions. What is an ion? Ions are atoms with a net non-zero charge. You're probably thinking to yourself, what? That sounds really crazy. Net non-zero. Well, that means that they just have a charge that is not equal to zero. +1, -1, -8, minus whatever. Okay, it's just not zero or neutral. So in other words, in order to get something that is not neutral, you have to have equal numbers of protons and electrons. So let me just, remind you guys here. If I have an atom, all right, so let me, I'm actually going to add in a separate blank page here. So if I have an atom in the nucleus, okay, so let me just draw a nucleus, you're going to have some number of protons. In this case, I'm going to put 3. And then some number of neutrons. I'm just going to put 2. All right, and around that, you'll have some number of electrons. Okay, so I'm going to do 3 electrons for now, and these go around the nucleus. Alright, so we can kind of draw in a dashed orbit here. This is my atom, the whole thing. Well, we know, and I hope that you remembered, that protons have a plus charge, alright, that electrons have a minus charge. And for each proton that you have, you can cancel the charge of 1 electron. So here you can see that I have equal numbers. I had 3 protons and 3 electrons, which means I had a balanced equal charge. It was neutral as an atom, so this overall would have a 0 charge. If we look at it mathematically, we know if we take protons, so 3 protons from my example, minus the electrons, 3 electrons from the example, I will get 0. This is my charge, so I have 0 charge. So this would not be an ion. Well, now let's mix it up a little bit. Let's get rid of this, and let's add. We can redraw it really fast. Okay. So once again, nucleus. We're gonna have. Let's do 4 protons this time, and still have the 3 electrons around the outside of our nucleus. I'm not going to put in any neutrons. All right. Well, now I can only cancel out. Okay, 3. And I've got this 1 that's left over. Okay. So this would be an unequal or unequal number of protons and electrons. So now I have a +1 left over, so my whole atom will have a +1 charge. Again, mathematically, 4 protons minus 3 electrons equals +1 charge. Okay, so hopefully you're starting to see how this all works together. Okay, so what can cause this? What can cause protons and electrons to become unequal? Because on the periodic table, every element that you see you can assume to be neutral unless you're told otherwise or you find experimentally that it is otherwise. Well, for now, I'm just going to kind of give you a cheesy answer. We're going to delve a lot more into this throughout the entire semester. So the cheesy answer is just that electrons move. Okay, they go everywhere. They can be added or removed from an atom. So electrons are really what's responsible for changes in charge 99.9% of the time. Well, okay, hopefully, if you're thinking, you're saying, well, couldn't you change the number of protons also to change the charge? Yes and no. Yes, if you change the number of protons, then you will change the charge as long as the electrons stay the same. However, protons are a lot harder to move. They're stuck in the nucleus. They're between all those neutrons, and they're held together pretty well in there, in that really dense nucleus. So it's unlikely that you're really going to be able to move protons around. It's not going to happen most of the time. So instead, it's a lot easier to move the electrons. So that's what we'll focus on. So how do you know if you have an ion? Well, calculation. Okay, just like we did earlier in this video with a little bit of example, you need to be able to calculate the charges. All right, so for example, we're going to look at this. We're going to examine this symbol thing right here. Okay, this is one way to denote the mass. Okay, so you guys can see the key here, the mass of an element, the atomic number, which is also equivalent to the number of protons, the charge, and if there's a subscript, which we don't have a subscript for these right now. Okay, so what does it mean? Well, if they're equal, if protons and electrons are equal, you have no charge. In this example, we can see that oxygen has 8 protons. Okay, 8 protons. And we also see that it has a -2 charge. So we can plug into our formula of protons minus electrons equals charge, which you can see right here. So if we plug that stuff in, all right, let's plug in what we know. All right, we know that we have 8 protons. We know that we do not know how many electrons we have. And we know that we have a -2 charge. So 8 minus x, where x equals 10. Okay. And this was an example in the electrons video that I asked you to solve, see if you could find x. I hope that all of you were able to. This is very basic algebra. In case you were not able to, and you're not sure how to solve that algebra, let's, I'm going to write it up here where it's a little bit bigger. Okay, 8 minus x equals -2. Okay, to solve this problem, there are a few things we can do. Least of which, okay, is if we just, we want to get rid of this 8. I'm going to kind of do it the long way, okay? So I'm going to add x to each side. So I'm going to add x here, okay, which will cancel that. And that makes it -2 plus x equals 8. All right. So then we can add the 2 back. So that'll cancel. And then we have 2 plus 8, which is 10. So 10 equals x. Okay. That's kind of the roundabout way to do it. I'm sure most of you can do that in your head at this point. If you're a little bit weak on your algebra, just go back, review it, study up, ask your math teacher a little bit. I will try and help you in class as much as possible. All right. So more examples. Well, let's look at them in terms of word problems. So our general concept is that you need 1 proton to cancel 1 electron. So if you have equal numbers, you have no charge. If you have unequal numbers, you have some charge, depending on which way you go. All right, so this one should be simple enough. 12 protons, 12 electrons. Well, I have 12 positives and 12 negatives. They cancel 1 for 1, so my charge should be 0. All right. You find a carbon atom with a +4 charge. How many electrons does it have? All right, well now we need to use our periodic table, so that's why I've got this up here. I'm going to blow it up so we can look at it here. All right, so we have carbon. Carbon is C. Carbon has an atomic number of 6. Okay. Please remember that the 6 is the number of protons. So if I have 6 protons, I have a +4 charge. How many electrons does it have? Hopefully, you're saying negative, or it only has 2 electrons, or 2 negatives. So to solve that, 6 minus x equals 4. 6 minus 2 is 4. 2 is our answer. All right. Go ahead and try this one. Okay, you have an element with 15 electrons and 11 protons. What's the charge? Try and do that one on your own. Take a second, pause the video, and see if you can do it. If you're not able to do it, please go back, review some of these other things that we've already covered, and then try again. All right, don't give up. Really try it. This is how you learn, just by doing the practice over and over. Just as in sports, where you need to practice throwing a ball over and over in order to be a really good pitcher. All right, you need to have practice with your brain in order to be really good at learning something and doing something. Now let's look at these symbol-based things. All right, I'm going to go back a little bit. Let's review this. Okay, I'm going to blow this up a little bit. This is important information to learn. All right, let me bring this all the way up. So we need to know what goes on the 4 corners of a symbol. These are a little bit different from the periodic table. When we looked on the periodic table here, all right, mass is in the top right on this one with the number on the top left, and the periodic table, they vary. You'll see numbers all over the place. Sometimes the mass is on the bottom, sometimes on the top. Okay, this is standard. This is what scientists use all the time, where you have mass is always top left, number is always bottom left, charge is always top right. Those are the 3 that you should really learn and focus on. We'll cover subscripts much later. All right. But there is a note here that you should know if there is no number. So let's say that there was no number right here. Okay, we'll scribble that out. That just means that it has a charge of 0. Okay, so we only write in numbers if they are different from standard, so to say, and standard would be 0. So the mass here is 4, atomic number is 2. You'll usually see these 2 may not be here. In this case it is. So let's use that information to do these practice problems. We have several symbols here. I'm going to do 2, and you guys will do 2. So let's start with this one. Well, we have a mass of 40. We have a proton count of 20, and we have a +2 charge. I'm looking for the number of electrons. Okay, so if I have 20 protons and a +2 charge, try and think of it as I have 2 more pluses than I have negatives. So I have 2 more protons than I have electrons. So I have 18 electrons. Now let's do it mathematically. Okay, that's the conceptual way. I have a +2, so I have 2 more of these than I have of the others. Let's do it mathematically. 20 protons minus x electrons equals a +2. Solve for x. So x equals 18. 20 minus 18 equals 2. All right? So you can always double check yourself. That's the really nice thing about these problems, is there's more than one way to solve it. So you can always double check yourself with an additional way to solve it. So really there shouldn't be any reason to get these wrong unless you're just being careless. Now let's look at carbon. You'll notice that carbon is missing a charge. As I said previously, this just means that I have a charge of 0. Okay? So it's not shown because it's understood to be 0 when it's blank. So I have 6 protons, a 0 charge, which means I have equal positives and negatives. So 6 minus x equals 0. I have 6 electrons. Alright, they are equal. Therefore, I get a charge of 0. Alright, I hope you're starting to get the gist of how to do these and what these symbols mean. So go ahead, pause the video, and do these two on your own. You've got 3 protons, a +1 charge, solve for electrons. You have 15 protons and a -3 charge, solve for electrons. Alright, keep that whole positive negative thing in your mind. Okay, finally, here are some additional practice problems. Some word problems and some symbol problems. Pause and try all of these. Okay, I hope you are able to do them. If not, please go back and review. So for review, what is an ion? Simply put, an ion is an atom with a non-neutral charge. It has unequal protons and electrons. Ions are formed as electrons move. Okay, electrons move. Protons do not. So what is the formula for finding charge? Okay, that was given. Go back and look at it if you forgot it. And what are the parts of this symbol? What does the 7 mean? What does the 3 mean? What does the +1 mean? What does Li stand for? Okay, start introducing yourself to this because you're going to see it a lot. Alright, so that's it for this video. I hope you learned something, and I'll see you next time.